Welcome back, class. I'm Mr. Teacher with the SAT Math Video Guide. Today, let's continue in number 10. A right circular cylinder with radius 5 and a height 4 has volume V. In terms of V, what is the volume of a right circular cylinder with radius 5 and height 8? So, for starters, let's find the volume of this cylinder, which would be pi r square height. So if we keep pi as it is, that would be 25 pi times 4. So 100 pi. If we were to increase the height to 8, then that would be 25 pi times 8, which would be 200 pi. In terms of 100 pi, 200 pi is 2 times more. And if you're wondering, well, what about the pi? We can cancel out the pi. The pi isn't where the party's at. The party's at tau. But so, in terms of V, the volume of the same right circular cylinder with radius 5 but height 8 would be 2V, which is choice B. Number 11 is a pretty convoluted problem. If K, N, and R are integers, let K, diamond, N, R be defined to be true only if N is less than K, which is less than R. If -2 diamond n, 0 is true, which of the following could be a possible value of n? So it just tries to confuse you with the symbol, which shouldn't be much of a confusion at this point if we've seen enough of the SAT's tricks. So over here we can see that r is the biggest number. This will be the biggest number, and therefore, since 0 is here, 0 is the biggest. So let's start setting up our inequality here. 0 is greater than K. K is the number on the left side of the diamond, in this case, -2. So we keep a gap, so -2. -2 is greater than which one? It's definitely not greater than -1. It's less than -1. It's not less than 3. Well, actually, it's not greater than 3, sorry, it's less than 3, but not greater than 3, but it's definitely greater than -3. And so, the only possible value of n is -3, which is choice A. Number 12 isn't too tough. If 20% of x equals 80% of y, which of the following expresses y in terms of x? So we already have our equation set up. Percentages are the number divided by 100. So 0.2 times x is equal to 0.8 times y. We need to find y in terms of x. So if we just bring it down here, 0.8y equals to 0.2x. If we divide both sides by 0.8, we get y is equal to 0.2 over 0.8x. And that cancels out to 1/4, or y is equal to 0.25 of x. And that's choice B, as it is 25% of x. Number 13 has to do with integers again. If x, y, and z are positive integers such that the value of x plus y is even, and the value of x plus y whole squared plus x plus z is odd, which of the following must be true? So before we go over this, let's consider the possibilities of each number being even or odd. In the first equation, it doesn't really help us much, as either one can be even or either one can be odd, and we just know for a fact that it's not one or the other. Either they're both even or they're both odd. So that doesn't get us much. What we need to look at is this x plus y whole squared. If you remember, even the multiples of an even number are even, and the raises of a number, is that the correct term? I'm not entirely sure, but basically, if we were to take any term and multiply it by itself, and if they're even, you would get an even result over and over and over again. So we know that x plus y whole squared has to be even, so we can get that out of the equation. So x plus z has to be odd. Now, we don't know whether x is an odd number or an even number at the top, and knowing what y is isn't going to help us at all. So now we start looking at the answer choices. Let's start from C. If z is even, then x is odd. Well, that works. If z is even and x is odd, that would give an odd result. And since there's no criteria about y, then y would also be odd, and that would be even. How about choice E? X times y is even. That doesn't help us much, because say x plus y were odd numbers, like 7 and 7. 7 times 7 is 49, which isn't even in the first place. If z is even, then x times y is even. Again, this doesn't really make much sense. If z is even, then x times y is even. If x times y were even, which would mean a square, then z would have to be odd, because x would have to be even, and x and z cannot be even at the same time. X is even, x is odd. Well, we cannot really assume that without knowing what y was in the first place. So the only choice that works is choice C. And do we have time to do another one? Let's do another one. I didn't get another one ready, but this seems very interesting, so let's do it. Okay, so if 0 is less than x, which is less than 1, which of the following statements must be true no matter what? So they give us options. X squared is greater than x cubed. Then x is greater than x over 2, and then x is greater than x cubed. Well, if it's greater than 0 and less than 1 and not equal to either 0 or 1, let's assume the exact middle number, 0.5. In the first case, 0.5 squared is 0.25, and 0.5 cubed is 0.125. 0.25 is definitely greater than 0.125, so that works. How about 2? Is 0.5 greater than 0.5 over 2? 0.5 over 2 is equal to 0.25, as 0.25 times 2 is 5. So that works as well. How about the third one? 0.5 is greater than 0.5 cubed, which is 0.125. That's definitely true. So that's correct as well. And so all of them must be true, and you can check this again. Let's say, let's pick 0.6. Let's make a line here. So 0.6 squared is 0.36. Must be greater than 0.6 cubed, which is 0.216. That works. How about the next one? Is 0.6 greater than 0.6 divided by 2, which is 0.3? Yes, it is. It works. Is 0.6 greater than 0.216? Yes, it is. So it works in any case that fits this criteria. So all of them must be true, and then the correct answer would be choice E. So I hope this helped you with your SAT preparation, and I will see you in the next video.